Here's question 2. We are asked to sketch the gradient function. Start with the turning points, and the turning points both have coordinates of 0 for the gradient function. Now I'm going to draw a gradient of 1, and you see the line doesn't actually ever get to 1, so below where I've got the green line crosses the original function, I've got a height less than 1, and then I can just sketch in my function. We're only asked to sketch the graph of the gradient function. Here we have a keyword, or we've given the gradient function, so we want the original function. So write out the gradient function, add 1 to the power, divide by the new x and the c go in there, and then we know that it goes through the point 0, 0. That means that the intercept must be 0. We want to find when x equals 3, so put 3 into that equation and we work out it's 45. We're asked for the coordinates, so write it as a coordinate. Here we're given the velocity and we want the maximum height. We're given the height and we want a maximum, so we've got to find the velocity. So differentiate, multiply by the power, reduce the power by 1. Because it's a maximum, the height will be 0. So we solve that for 0 to find the time. So at 1.224 seconds, the ball is at its maximum height. Put that into the height equation, and we can work out what the actual maximum height is. Calculate that. 8.35 meters. That's pretty easy. Here we're given the acceleration, we want to find the velocity. So we write out the acceleration equation and then add 1 to the power, divide by the new power, add your t, add your constant. Now it says the initial velocity is 40 meters per second, so that means that the constant is 40 meters per second. Once we have our velocity question, we are asked after 2 seconds, so put 2 for t, run that through your calculator, and that's another easy merit question. As long as you know when you're given the acceleration, you've got to anti-differentiate to get your velocity. Here we're asked for when is this function increasing. Well, it helps to know what the cubic function looks like. That's a cubic graph. And it's decreasing between the two turning points. So that's where it's decreasing, so it's increasing in the parts that are not shaded. We have to use calculus, so let's differentiate. Multiply by the power, reduce the power by 1. Find the turning points, so we make it equal 0. Factorize, and the turning points are at -2 and 6. So it is increasing when x is less than -2, and it's increasing when x is greater than 6. You could double differentiate it and put points in to prove that it is increasing as long as the answer is negative. For this one here, we're asked to find the graph of the function. We're given the differentiated function. Note the turning point is when the gradient is 0. So we know the turning point is 0, -6. So put 0, -6 down there. Now the gradient function has a straight line, y equals mx plus c. So the gradient function is 2x minus 4. That's the line of that graph. We can then find the actual function by adding 1 to the power, dividing by the new power, putting your c on the end. Use the point that we've got of +2, -6. Use that point. Put it in to work out what the c is. We find the c is -2. So now we've got the actual function, and we can find the coordinates and sketch it in. There's excellence.